Okay, what are the possible factors of 6? Plus or minus 1, plus or minus 2, plus or minus. So we'd have to try those, correct? Or if it was on a test and I said, what are the possible factors? If I had like x plus 1, x minus 7, x minus 4, x plus 5, it would be the one with the 1, right? Because the other 3 numbers didn't appear in any of those, right? And some people will call me over and they'll be like, none of them work. It's because I said possible. It doesn't mean it actually has to work. It's a possible factor, right? Now, which one does work? What are the x's that we get?
-2 and 3.
And 3. So we're suspicious that this is decomp because there's a number in front. I told you that. You're like, what's decomp? Doesn't matter. We're going to dust it off. We'll bring it back. When there's a 2 in front, we're going to end up having to do decomp, which ends up giving you like a fractional x, a fractional root. So hence why I have -2 and 3 doesn't mean there's probably only 2. There's probably a third. Well, there is. And it's going to be a fractional because we have decomp. Okay? So the more you know, the better it is, so you can be prepared. Like you see 2 and you're not freaking out. You're like, oh, the other one probably has to be a fraction because I'm going to do decomp. So I'm going to use -2 because I always try and use the lowest one so that we all have the same thing, even if I say, hey, try it yourselves. If you always start with the lowest one, you'll do it the same order as me. If you want to be a rebel without a cause, do the other one. No big deal. So I have x plus 2 as my factor, and I go down here and I go x plus 2 immediately, so I don't forget about it, because that's what happens. And then I say rocket counting. 3, 2, 1, 0, blast off. I'm good. So I can put my coefficients. 2, -1, -13, -6. And then the first thing I do is I drop down the 2, and then I multiply. -2 times 2 is -4. Then I add. -1 and -4 is -5. Then I multiply. -2, -5 is 10. Add. -3. Multiply. 6. And then I'm happy because this needs to be a 0, right? Now, if this is an x cubed and I took an x out, what's this going to be? X squared. So I'm going to have 2x squared minus 5x minus 3. Now, yesterday, we did what times what gets us the outside, what plus what gets us the inside, and we can go straight to brackets, right? Well, we can't go straight to brackets because there's actually a 2 in front this time. So we have 2x squared minus 5x minus 3. And we go what times what equals -6, the outside 2 numbers, and what plus what equals -5. So, what 2 numbers are going to work? Yeah. So we're going to get 1 and -6. And if you do the blanks, you can check it. 1 times -6 is -6. 1 plus -6 is -5. Now with decomp, we were taught that we can replace this with these, because 1x minus 6x is the same as -5x, right? So with decomposition, we can't go straight to brackets, but we can replace the -5x with 1x minus 6x because that is -5x. And that's the reason why this front and this back don't change. They stay the same. So we're going to get 2x squared, and then a minus 3 at the back, and then the middle gets replaced with positive 1x minus 6x. Now, could I have went minus 6x plus 1x? Yes, you will just get the opposite factors in your bracket. That's it. That's all that's going to happen. So we're going to take an x out. If we do this, we have to put a plus sign in between, because if we just have brackets touching, that's actually multiplication, which is not what we're doing. What can we take out of the first one? An x. And then we're left with 2x plus 1. Now you take something out of here, so I'm left with 2x plus 1. So I'm going to take out a -3, and I'm left with 2x plus 1. And then in this term and this term, they both have a 2x plus 1, so I can take that out. And then what's left over is x minus 3. So I have x minus 3 and 2x plus 1. Now I'm going to prove a point. Just if you forgot about decomp, I'm going to prove a point that if I flip those, it doesn't matter. So I'm going to go 2x squared minus 6x plus 1x minus 3. So I only just flip the middle. Remember, understanding is more important than memorizing. So if we take a 2x out, we're left with x minus 3. And then I can't take anything out because it matches, so I get a plus 1. and I get x minus 3. So if you just pick the opposite ones, look what's in the bracket. X minus 3. Look what wasn't in the bracket. X minus 3. Look what's not in the bracket. 2x plus 1. Look what was in the bracket. It just flips the factors out. So don't like freak out if you see someone doing it flipped, because you should get the same answers. Does that make sense? Yeah.
When writing the factors out to formalize, does it matter what order?
It's multiplication, so it's a commutative property. So 4 times 2 is the same as 2 times 4. So this times this times this is the same as flipping all three of them. Yeah. Okay, we're going to look at D. Type it in. Find something. And then we're going to move on to the next 4. What are the possibles? Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Now, on the diploma, they could give you a written response and say, determine what the possible integral zeros could be and why. And so you'd have to explain that. So the thing about understanding, you really do need to understand, because I don't know what they're going to give you for written response. They give you whatever they want. And they can have explains, compares, describes, verifies. And the wording ones are the ones that are done the worst. So we'll practice. So, which are the x-intercepts when you go to your calculator?
-2 and 1.
-2 and 1. So, we take this. I'm going to pick x equals -2. And I'm going to go x plus 2. Then I'm going to go to the bottom and I'm going to go x plus 2 so I don't forget about it. I'm going to say, can I count down? 3, 2, 1, 0. Yep. Put in my coefficients. Drop the 2. -2 times 2 is -4. Add it is 3. -2 times 3, add it is -6. Multiply. Add it now is -6 plus 1 is -5. Multiply -2 times -5 is +10. And I get a 0, so I know I didn't make a mistake. Now this is a cubed. I took an x out, so this is going to be a squared. 2x squared plus 3x minus 5. So what multiplies to give me the outsides? 2 times -5, which is -10. And what adds to give you the inside, which is 3. And what do we get? 5 and -2. Which we're going to replace this with. So I start off with a 2. So I'm going to use the 2 first, just because sometimes it's easier picking them out of order, but it wouldn't have mattered if you do pick them the other way. So I'm going to go -2x plus 5x, and then rewrite my 5. For someone who's like decomp, I still don't get it. Come in and ask questions. We'll remember in like 5 minutes. We can review like 3, and you will rock them. Okay? Take a 2x out. We're left with x minus 1 plus 5. We're left with x minus 1. So you should get x minus 1 and 2x plus 5. So before we move to the next page, if it says factor, that's factor, right? Factors are when you have x plus something, x minus something, 2x plus something, 2x minus. Those are your factors, right? So I can ask this question, which I did at the very top. I told you to factor. But what if I had told you to solve? I'll learn a little bit of that today too. What if I told you to solve? What does solve mean in the world of math? Doesn't matter what class we're in. What does solve mean? It means solve. Yes. So solve means solve. Choking on his water. Solve means solve. So good. Who said solve means solve? Was it Brian? Yeah. Okay. Solve means solve. True. So does blue mean blue. But when you see solve, it means I'm giving you an equation. You need to tell me what the heck the variable equals. So when you see the word solve, you know at the end you need to have variable equals number and box it. So variable equals number and box it. That's what I'm looking for. When you say solve, it doesn't matter what unit you're in. It doesn't matter what math curriculum you're in. Solve means in the end, I'm going to have whatever the variable is that they gave me in the question equals a number. Box it. That's what solve means. Okay? So if I say solve, these all have to be set equal to what? 0, because you're finding the whats.
Zeros.
The zeros, the x-intercepts, the roots. So really, you're finding out what x equals, you're also finding the x-intercepts of the graph. So if I said solve, you go one more step. X plus 2 equals 0, x minus 1 equals 0, 2x plus 5 equals 0. We're going to subtract 2, x equals negative 2, add 1, x equals 1, and then 2x equals negative 5, divided by 2, x equals negative 5 halves. This is done the poorest, because I'll ask you to factor and you'll solve. I'll ask you to solve and you'll stop at factoring. It's very different, right? Factors are the things that are in brackets, correct? Solve means set them equal to 0, go one step further. That's it. So on a diploma or on a unit test or on a cumulative, if I say solve, I need x equals or m equals or whatever the variable is equals number, right? Go that one more step further. But if I say factor, you stop at the factors. It's the worst thing done on the test, actually, because you don't know where to stop. And you're like, but if I keep going, you know more. I'm like, but I asked you to factor, not to solve, so it actually doesn't. It is not helpful. Okay? Flip over. We have an x to the 4. The x to the 4 has a 1 in front. So am I going to have to do decomp or product sum at the end? Product sum. Guys, sometimes you can't factor. So if you can't factor and I say factor, be happy. You just box it. You have a quadratic factor. That's it. You can't do anything. However, if I say solve and you can't factor, you're going to have to use the quadratic formula. So if I say factor and you can't factor that quadratic at the end, you're happy. You have two linear factors and that quadratic factor, you box it, you're like, life is good. If I say solve, you can't factor it. These ones will work out easy. That one you're going to have to use the quadratic formula. So we're going to look at the x to the 4 here. We know that it's going to either be product sum or nothing, right? Because I'm asking you to factor, not solve. So what are my possible zeros? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. And this is when you're so happy you have that expensive calculator in front of you. Because if not, you're guessing checking for a while. So everyone type the x4 in. It's no different than the x cubed. Does anyone have the x-intercepts on your table?
-2, -1, 3.
Should be one more.
I don't think so.
That's it?
Yeah.
Possibly 4. Why can there be 4 this time? Could be 4 because it's the power of 4. Note to self. I know they have to all be whole numbers because there's a 1 in front, right? I only have 3. Sounds a little weird. Press graph. We really need to get a graph up on this computer. This is so bugging me out. Press graph. Okay? Look at your graph. Every time it goes straight through, that's 1 x-intercept there, right? You were taught last year that every time it hits the x-axis and bounces, there's 2. So we may only have 1 number here for one of them, but there's actually 2 added. Where's the bounce happening?
3.
At 3? So we're going to get 2 times where we're going to get x minus 3 and x minus 3. We better get that 2 times because it bounces there. The professional word for bouncing is called tangent. Okay? So when we have the bounce, it's called a point of tangency. Tangency just means it touches in one spot. So in grade 9, you would have done circle geometry. It was the weirdest unit ever because it just got thrown in there. It used to be in grade 11, and then they tossed it into the grade 9 curriculum. And anyways, you were taught about a point of tangency. It was when you had a circle line and then a circle, and then the line just went on the edge and it touched in one spot. That was point of tangency. Same thing here. Touches in one spot. Okay? Point of tangency. When that happens, you get two factors. Or you could say two x-intercepts there. They just have to be the same x-intercept, right? Yeah.
Would you put the possible factors for every question?
I would practice it because what happens is on a test, if I gave that question, it's done terribly because people forget what possible factors are. So I would do it like 800 times so it's embedded in your brain for life, but you don't have to. So I'm going to use -2 because I told you I used the smallest one. Could you use any of them? Yes. So I'm going to use -2. My factor is x plus 2. So I'm going to have x plus 2 down here. I also know I'm probably going to have an x plus 1 down here. I know I'm going to have an x minus 3 times x minus 3, which I could just write as x minus 3 squared. So that's what I'm looking for, because that's what it told me, right? So I say rocket counting. 4, 3, 2, 1, 0. Yep. So I can just write them. I don't need any placeholders. I drop my 1. -2 times 1 is -2. Add it. -3 and -2 is -5. Multiply. -2 and -5 is 10. Add it. -7 and 10 is 3. Multiply. -2 and -3 is -6. Add it. 15 minus 6 is 9. Multiply. -2 and -9 is -18. And I'm happy because it matches. Correct? Today's lesson is not ridiculously hard. So we did one synthetic division and got here. Correct? It was an x4. I took an x out. What am I now at? X cubed. And then people go, but I don't know what to do next. Yeah, you do. You just did this. Do it all over again. You literally just did this, right? We just did x cubes. We rocked them. We're so good at them. They were just amazing. So how did we do an x cubed? Yeah, so you just did start with possible factors. Type it into your calculator. Look for an x-intercept, right? So go. Look for the smallest x-intercept. It might be -1. Possible. If I gave you an x5, what would happen? You have to do synthetic division 3 times. Your x5 would knock you down to your x4. Your x4 would knock you down to your x3. Your x3 would knock you down to a product sum or a decomp, right? Works. What number works? X equals -1?
Yeah, -1
And 3. So I go down here and I put the x plus 1 right away, because I'll remember this one, then I forget this one, right? So we have to keep going. So now I can count down. After this point, once you do the placeholder once, you're never going to have to do it again because you made it have its places, right? So 1, -5, 3, and 9. Drop the 1, -1 and 1 is -1, add it is -6, -1 and -6 is 6, add it is 9, -1 and 9 is -9, which is 0. And now because this was an x cubed, this is now going to be x squared. And what multiplies to give me 9 and adds to give me -6? Shockingly, x minus 3 and x minus 3, which is where we knew where we were going. So sometimes actually typing it into your calculator first, finding what you know, looking at the graph can lead you to this and be like, you know where you're going. So when you get there, you're like, yes, I rock. Or if you didn't get there, you're like, oh no, what did I do wrong? Okay? because x minus 3, you'll call it squared. So now what would my x-intercepts be? This is how we would write them out. We'd say x equals -2. We'd say -1. And then how do we let the world know that there's 2 at 3? How do we let the world know? Well, they decided back in the day. I don't know when back in the day. They decided how you can let the world know that there's 3 there is you say 3, and then you follow behind it when it's a root. When it's a factor, it's easy. You have a 2, right? Boom. But when it's a root, you'd say 3 multiplicity 2. Multiplicity 2 just means you have 2 there.
What's the symbol for that?
Multiplicity 2, there's no symbol.
There's no symbol.
No. So they can either say 3 multiplicity 2, or they can say there's a point of tangency at 3, because the point of tangency means 2. They can use them interchangeably, like zeros, roots, and x-intercepts are interchangeable. Multiplicity 2, or point of tangency at 2, interchangeable. Does that make sense? So can you grab out a separate sheet of paper? Instead of doing this one for homework, I'm going to make you do it now. So this would normally be part of your homework, but then it's done terribly, or you just get stuck, and I don't want you to get stuck, okay? You get stuck because I've shown you one like in class. So like, how do you do something when you haven't seen it, right? So 6E will be like this one, but you'll have done this one, so it won't be so bad, okay? Once you see it, you're like, oh, that's not hard at all. So this is 6C in your textbook, just so you know. And it says factor fully, but we're going to factor and we're going to solve this one. We're going to factor and solve. And it is h cubed minus 27h plus 10. H cubed minus 27h plus 10. So that would be factoring. And then if they asked you to solve, they'd say h cubed minus 27h plus 10 equals 0. They have to set it equal to 0 in order to solve, right? So we're going to factor it first, and then we're going to solve it. What do I have to check for? The countdown. The rocket. So I have 3, 1, 0. Oh, sounds like a terrible rocket countdown. So I, for myself, will go h cubed plus 0h squared minus 27h plus 10. Do I have to type it in with the h first off? No, I can press the x. That's why the xt theta n button exists. You can just press that one because it means every variable. Some people do alpha x and get the x that way. I would just press the xt theta n button because I'm lazy. I didn't know people didn't know you could press that button. So just in case you're someone who doesn't know that, it's the xt theta n button. It's beside the alpha button, I believe, below the mode. Yeah. Okay, do you have to put 0h squared or 0x squared into your calculator? No, that's just for our placeholder help. So go type it in. And you're going to factor this, and you're all going to rock it, I believe. So this question on a test, for example, could be in the multiple choice. And it could say, determine the quadratic factor, which lends me to believe that something doesn't factor, right? So linear factors are the ones that if you put a y equals in front of them, they would make a line, correct? They're also to the degree 1. Then there's quadratic factors that are to the degree 2. And a quadratic factor, if you end up with one, means it didn't factor. Now, how they amp this question up, okay? They'll say one of the factors is, and we'll talk about that in a second, what are my x-intercepts? What's the only one that shows up? -5 or 5? 5. So what they might say is, one of my factors is x minus 5, determine the other quadratic factor, which this one has to be a quadratic factor, it won't be able to factor, correct? On the last questions, though, on the last questions we had, they could factor, couldn't they? They could all factor. So what they might say is, determine the quadratic factor if one of the factors is x minus 3. So they force you to do synthetic division with one of them, and then you give the quadratic factor that's left over. That's another way they can do it that trips people up. Okay? Or they'll say one of the factors is x minus a, determine the other factor, and only one of them is x minus. So you have to find that one. You have to find the positive one, right? The positive x-intercept, and then get the quadratic. So they do word it weird sometimes to force you to give them a certain quadratic. So we're going to use 5. It's the only option we have. X equals 5, which means our factor is x minus 5, which is a linear factor, which I'm going to write at the bottom so I don't forget about it. Can I count down? No, I couldn't, so I have to put a 0 in. So it's going to be 1, 0, negative 27, and 10. Drop the 1. 5 times 1 is 5. Add it. 0 plus 5 is 5. Multiply. 5 times 5 is 25. Add it is negative 2. Multiply is negative 10, which I get a 0, which I'm happy. Then it's an h cubed, so this can be h squared. Don't switch it to x's. It will be a habit that you have because x's are embedded in your soul. Okay? Always look back and see what the variable was. See, embedded in my soul. Look what I did.
Oh, that's not good.
Embedded in my soul. So I have to watch myself. So this is actually h minus 5. Okay? Because there is no x's in this question. Now, what multiplies give me negative 2 and adds give me 5? Nothing. 2 and 1, the largest I can get is 3. And they would have to be different signs. So the largest I can get is 1 or negative 1. Neither are going to work. So this, if I say factor, you should be like, woohoo, party, no work here. At h squared plus 5h minus 2. Box that baby and move on. Life is good. I am happy. You guys sit there for years and you're like, it must factor. It doesn't. Okay? Yay, done. If it says solve, you might get a little sad, unless you're like I love doing the quadratic formula. It calms me. If that's the case, you'll be so happy when you see this. Okay? Great thing about quadratic formula is if decomp falls out of your head, right, and I ask you to solve, and decomp has fallen out of your head, could you type it? Could you put it into the lovely quadratic formula and get an answer? Yeah. So if all of a sudden you're going to go decomp and it says solve, and you're like, it is my brain, it's done. Quadratic formula will always give you the answer, right? Factoring works sometimes. Quadratic formula works all the time. I wouldn't suggest that's the route you go. It's quite longer. Let's make it longer. But you could use it. So I asked you to solve over here. So we have h minus 5 equals 0. H equals 5. Woohoo! Done. That one. Then our life gets good. We have h squared plus 5h minus 2. And actually, it causes me to be calmed. I really do appreciate this. Now remember, people are like, I don't know what form it has to be in order to use it. Wow. Is the Alberta government not nice? Look up here. It says for ax squared plus bx plus c equals 0. It tells you what's in front of the x squared is my a, what's in front of the x is my b, what's the back is my c, and it has to be equal to 0. If it's not equal to 0, you need to put it in that format, right? It tells you this format is the only format I can have to put it into there. How sweet are they? Kind souls, right? So, a, b, c. So we have x equals negative b plus or minus the square root of b squared. So 5 squared, which I put in brackets because it's negative, it'll become positive. B squared minus 4 times a times c. And where the big error comes in, the whole thing, numerator, the whole thing over 2 times a. And like the quadratic formula of yesteryear, or last year, or I think, was it last semester? Was it first semester when you took it? I don't remember. Last year sometime. You have to reduce the radical. Often they ask for it in exact values. Remember, exact values last year screamed, reduce my radical, probably going to turn into a decimal, right? Decimals are not exact values. Okay? So we're bringing back last year's grade 11. So we have x equals negative 5 plus or minus, and we just do this whole thing. So this is going to be 25 minus 4 times 1 times negative 2. This is, whole thing is 8, and this is 25, and 25 plus 8 is 33. Can 33 reduce it all? No. I'm going to remind you, if it wasn't 33, let's pretend it was 24. let's pretend it was 24. It is not 24. Possibly don't write this near what you're doing, because you're going to be like, oh, where the heck did 24 come from? If you do, put a little box or something, a little reminder, you know, like, so it's not part of your question. So you don't, like, question your brain. 24. This isn't actually reduced, because there's a perfect square I could take out of it. What perfect square could I break 24 into? 4 and 6. Some people tell me 8 and 3. Those are two lovely numbers. Both are not perfect squares. 12 and 2, also lovely. Both not going to help. So we're going to do 4 times 6. The reason why I picked 4 is because the 4 can come out and it becomes a 2. And so then I would get 2 root 6, right? Root 33. 33 is a prime number. Is anything happening there? No. Okay, that's my one reminder. My second reminder. Say we have x equals, once again, nothing to do with this question. Say we had negative 2 plus or minus root 24 over 6. Let's say we had that. Right? Say that was our answer, not this 33 garbage that we got, which made our life substantially easier, just so you know. Say, ooh. I'm just going to stop moving it. Okay, so the 24 we know broke down into 2 and 6, right? Right? Last year you were also taught about quadratics, that the only way you can reduce, there are 3 terms here. This is one term, this is the second term, this is the third term, right? So unless you can take out a 3 for 1 special, it ain't happening. So can I take something out of all 3 of these? The 2. 6, please do not cross that off. It has nothing. The only way you can get rid of this to reduce is if you can take a perfect square out, right? So once again, for this one, I could take a 2 out, so this would be a negative 1. I could take a 2 out, this would be a positive 1. I can take a 2 out, and this would be a 3. This, if this was even a positive 1, you'd have to keep it. You can't make it go away, because it would be 1 plus or minus this, right? The only 1 that can completely cancel off is if the denominator turned to 1, you wouldn't need it, because you don't have to write over 1. And if there was a 1 in front of my square root, I don't have to write it because it's 1 times. But if there's a positive 1 here, it has to be written. And that was last year taught too. So I know this is weird and doesn't mean anything. I'm just reminding you of when you do the quadratic formula, how do you reduce a radical? Because you have to. And how do you reduce this? If it's only, so say this was 2, 2, and this was a 5 down here, nothing would be happening. You would be done. It can never be a 5 down here, just so you know, because it's 2 times something. It has to be an even number. It's a terrible example. Like an 8 or, yeah. Yes. Okay? So let's go back here. You might be like, oh, it's going to be down, but that's okay. You might be like, root 33, that's stupid. Throw a party. That is a number that can't reduce. If it can't reduce, you are done, because nothing can come out of it. If nothing can come out of it, nothing can cancel off, right? It's going to be a 1 in front. So when this is a prime number, I'm just like, thank you, question. You are amazing, okay? If it says exact values, which it will, because they're testing you on reducing radicals and reducing quadratics, if it says exact values, unless it's a numeric response, sometimes they turn it to a decimal. If it says exact values, you turn it to a decimal, you are losing marks. You did the question perfectly, and then you kept going, and you should have stopped, right? So stop. So the answer for this one, I would go x equals, it's not an x. It's not an x left. See? The addiction. The addiction is real. It's an h. H equals 5, comma, negative 5 plus or minus root 33 over 2. Done. Okay? So, for your homework, I'm going to assign 5 questions. They all say factor, but I want you to also, what do you think? Solve. There's only one that's going to cause you to do this. It's the last one. Okay? You all look so sad, but this is like calming. Calming.
No.
Yeah.
I'm checking your assignment. Like tomorrow.
So Friday. Yep. So you're going to put them in your duotang, and then I get them for the weekend. You get them back on Monday.
Which questions like do we need?
So if you look in Google Classroom, I have homework September, I think 3rd to 9th. And then in there it'll say September 3rd this, September 8th this, September 9th this, and you just look and you just make sure you have all that. Okay? And then next week I'll start a new post with the new homework post. Okay?
I'm sorry.
Page 134. 5DE, and 6ABE. Now some people might say, but it only has the factors in the back left. How might I get the answers for solving? Your calculator gives you the answers to solving, doesn't it? And it'll give you the decimal answers, won't it? So you'd have to go -5 plus root 33, enter, divided by 2, see what the decimal and see if it matches. You know how to find the zeros. We went over it. Second, trace, number 2, which said zeros and left bound, right bounds, right? You can check these. It's a wonderful thing. You paid a lot for those calculators. Get the money's worth, you know? Some people are on calculator 3, so you really need to get the money's worth.